You know, I sometimes wonder if there's really any magic left in the world. It may be in arts like ours. High technology, low technology, how to get in things, how to get through things, cars, houses, buildings, safes. By the way, this trick really works on almost all Volkswagens. Here we have a typical fairly heavy wooden deadlocked, dead-bolted door, difficult to open. Of course, we can pick the lock, we can chop through the door, a number of ways to get inside. One of the things we want to accomplish in this is to start thinking of ways to go through. In other words, to circumvent the lock. We don't have to unlock this door to get in if it's done right. All we have to do is go through this obstacle. One of the ways to do that, a number of years ago, people came up with the idea of taking a car jack, usually a hydraulic jack, for instance. You can tell that this exerts quite a bit of pressure. It'll lift up an American car. You can take the jack, put it in between the jambs. It's theoretically possible to move this massive wooden jamb with enough pressure over far enough to let the latch, even in this case an inch, inch and a half deadbolt, come out of the door. Now, obviously, jack isn't going to make it all the way over. So the way people did this was took blocks of wood, propped the jack up, tried to extend it out as far as they could, put other blocks of wood in front of the jack to press against the jamb. From personal experience, I can tell you this is really rough. A lot of jacks don't work upside down. The wood will bend, the wood will pop loose. It's a very cumbersome, inefficient operation. A screw jack is sometimes a little bit easier. The trick is to get as close to the jamb as you possibly can if you're going to use one of these. Well, a couple years ago, somebody took this concept and thought, you know, I can do a better job. And as such, we have a tool known as the jam spreader. This is manufactured by Omni Concepts in Vista, California. It's also sold by Schomertech, a number of other people. Same principle. It's a hydraulic jack. Easy to extend the legs all that distance, get it in tight on the jamb. Got a handle, folds up, store, hydraulics, on and off. This will put out about 4,000 pounds of pressure in order to spread the jamb. That is enough to spread most jams without too much damage. Will not spread heavy metal jams in large buildings. We've got the jam spreader in place. It's horizontal, the correct side is up, tightened down. We're as close to the jamb as we can be comfortably. We're going to apply pressure. You're going to hear the jamb creak as it starts to spread open. It's moving the jamb away from the door. You can hear that noise. Pulling the deadbolt out of the door. Now, this is not a huge deadbolt, but it's reasonably sized. I'm going to apply this pressure. I can feel the door starting to go right now. It's creaking, giving way. That has probably just popped deadbolt loose out of the door. Doesn't leave any permanent damage. Makes a few marks. Release the pressure. See the jamb come back in. So we do that. This is the Omni jam spreader. Obviously, it's on a fairly easy door. We don't have a deadbolt. However, the door is locked, and the latch extends quite a ways into the wall. We've already set it up here. Could be a little more horizontal, but we're going to try anyway. Give it a couple squeezes here. You can hear the frame starting to go. And see what happens. By God, now watch. You didn't hear much there because the door opens outward, so it's hitting the lever of the jam spreader. So we take the jam spreader off the door. Now you notice it's still locked. All we did was spread it away from the jamb, approximately ½ an inch, enough to let the latch slide out from the door. We shut it again, and the door is locked. That's how the jam spreader works. There's not a lot of damage. In this particular instance, because these are sort of stuck on the jamb, it is beginning to pull these loose as we did this. Both of these are pulling loose a little bit. And if you look closely, you can see some marks where the jam spreader sat. However, for the most part, not a lot of damage. It opens the door, doesn't harm the lock, doesn't harm the jamb if it's done right. A few seconds, you're in.
These are an example of state-of-the-art opening tools. They're designed for emergency opening situations. They work well for that. They also work well for normal opening situations. These two tools are very similar in nature. They're hydraulic openers. This one is called the Hydroforce and is made by Iowa American. This one is called the Rabbit tool, and it's made by the same people that make the Jaws of Life. The way these work: apply hydraulic pressure by pumping, forces the door back and open. In about 20 to 30 seconds, these tools will literally rip open most doors, be them hollow core, solid core, whatever. Well, you have to remember we're dealing with high pressure hydraulic fluids here. We have to take certain precautions. But if you handle these right, you can walk up to a door, stick it in, and open the door. Really amazing tools. These tools, as we say, are very similar in nature. There's a couple differences. The tool from Hale Fire Company, Jaws of Life people, is pre-assembled. All the connections are fitted. It has 5 little toes to force the door apart. The Hydroforce tool is not pre-assembled. It uses quick snap connectors. You'll see me put this one on. It's all it takes to assemble it. A little easier to store because you can take it apart. The force appears to be about the same on both of them. That is between 8,000 and 10,000 pounds hydraulic force. That's a lot of power. It can rip open most doors. This one also has a spring-loaded feature that keeps it open until you force it down, where the other one doesn't. But that's no big thing. Basically, they work the same. Now let's take a look at exactly how this works. Take the foot, so to speak, put it in the door jamb. Both of them have a strike plate on the back. This strike plate means you can hammer it in with a sledgehammer if the door jamb is not wide enough to accept the tool. Once you get it in, set the lever on closed, hydraulic lever, and we pump it up. Now watch the tool in my hand, and you'll see it open. It'll actually open about 4.5, 5 inches. Now, if that doesn't open your door, you can walk in, because that's pretty wide. 10,000 pounds of pressure right here. Ugh. Opening the door. When you're done, simply reach over, click the release, down it goes. That's how they work. Hydraulic pressure from here through the hose, very high pressure, grabs the door, forces it open. Pound it in if necessary. Let's look at some safety features here. Because these tools use very high pressure, there's always a danger that the hose could burst. You could have things flying off the door. Also, can have a problem, at least this one. When the tool pops out, some doors will open very slowly. The door is open. Some doors will rip off suddenly, possibly breaking the door, possibly throwing the tool out. So you always want to use extremely heavy gloves. Here we have welding gloves. Protect your hands. Protect your hands from flying metal, from the door, from the tool coming out. Should have boots on. Watch your feet. Keep them out of the way of the tool. Always wear safety goggles when you're using this. Protect your eyes from flying things. And preferably a hard hat. Okay, with this in mind, let's go up to our test doors and take a look at how these tools work. This is an example of a solid core door. A fire door. Heavy, hard, difficult. We've installed a long throw deadbolt in this hole. Keep this door in place. The door is solid. I'm going to take the Rabbit tool and see what it does. The jamb has enough room that I can slide the tool in without hammering, so we're in. And now, we got it out so we could get it with a small kick there. We rip the lock from the top. Let's go in this way, finish the job. Because the deadbolt's so long, is it's spreading this much, but as you can see, the door is ripping right off the bolt. And in fact, now the door is open. Pretty good for a long throw bolt. Ripped it right through the solid core door, tore it loose. Ripped the deadbolt completely out of the hole, tore it loose. This is an aluminum frame door. sturdy. We've got our rabbit tool now. We don't have a jam to put it against, so we cannot open it traditional way. What we're going to do is use the tool as if it's a jam spreader. We're going to put it in here and see if we can force the jam apart and pop the 2 deadbolts here. Let's see what happens. Does force it very easily. Takes it right out of the frame. Now, of course, this door opens inward, so we're going to pry it to open and see. And there we go. The door's open. So it can be used on a door even without a jam, using it like a jam spreader. Force the frame away, and you can see the length of this bolt, how effectively it forces it. Even though our door is not in a wall, not reinforced, principle still applies. It bends the metal, forces the door out. Very, very handy tool. This is the Hydroforce tool. This door is nailed shut. It's barricaded shut. It's akin to a hostage situation or a situation where somebody's barricaded the door shut and nailed it shut. Let's see what the tool does. First of all, we can't get it in the jam because the jam is now nailed completely shut. So to pound it in, forcing the door back by hitting the strike plate. Once we get it in, a couple of pounds, let's see how many strokes it takes. 1, feel the door starting to go. I didn't get that all the way down. 2, 3, and the door is about to come off. Now we have to watch it here so we don't The door is effectively off right now. Latch has just fallen out. It's open. That's how long it takes. I could have done that faster if I'd been professional with this tool, obviously. You can see the nails on the door. The door was barricaded shut. Nailed shut with strong nails. That's how long it takes to open it. As you've probably seen from a number of police shows, this is a ram. Heavy. Outer layer, usually concrete inside. This particular one has a couple of advantages. This is from B-Safe company. This is light enough that one person can use it. Most rams require 2 people to use effectively. This has flexible handles, easy to grab. I can stand out of the line of fire. If this is a hostage situation, I'm going inside a door. Don't hit over here. You're putting yourself right in the line of fire if someone's inside. The ram is just as effective hitting from the hinge side, if not more effective. If there's a fox lock on the door, a bar running to the floor on the inside, hitting it on the hinge side torques the door and rips it away from the fox lock. This ram will develop somewhere around 14,000 pounds of pressure when swung against a door. Because of the physics of motion, the weight of the ram, and my size, we get about 14,000 pounds of pressure. This door is nailed shut on the opening side. Let's see what happens. Let's try the hinges and see if it goes. I'm going to stand out of the line of fire a little bit and hit the hinges. Could have done it 1 if I tried. Not bad, nailed shut. 2-person ram. It's heavier than a 1-person ram. Heavy steel. We're going to try and ram this door open. Obviously it's a hollow core door, but it is nailed shut. Okay, we're going to hit right here and go. My gosh, that works pretty well, doesn't it? Nailed shut or not. 1 little tap. Solid core door. Nailed shut onto a metal door frame. Very, very sturdy proposition. Take the 2-man ram and see what happens. First, we'll hit it near the hinge side, see if we get a reaction out of that. Ready? And go. And go. And go. Not bad. This device is called a K-tool. It's also from B-Safe Industries. Comes in a nice little leather carrying pouch. Give you a couple of other things with it. A shove knife, opening spring latches, works real well. K-tools have been used for years by the fire department. Have very sharp edges on them. Take any rim or mortise cylinder lock. The K-tool can be shoved with its razor sharp edges over the lock. And you take a hammer, you tap it onto the cylinder. Locks it on the cylinder. You take another tool, Halligan or our duckbill or a big crowbar, stick it in here, pry it out, and it will rip the cylinder right out of the door. This is an aluminum frame door.
nice heavy cylinder. We haven't practiced this. We're going to try it. We're going to take the K-tool, put it on, try and rip it out. Let's see what happens here. We want it on the cylinder, not on the guard ring. We're going to use our handy duck bill. See if I can tear it out. Out of the door. Aluminum frame door. Now, of course, you can reach into the screwdriver, trip the mechanism, open the door. That's how fast. Does damage the lock a little bit. Damages the screws holding it in, of course, but pulls it right out. In some situations, it may be imperative to get through a door very quickly, such as SWAT applications, hostage applications, any kind of emergency application. One way to do this is by the use of explosive charges. There are available shaped, extruded C4 charges with foam backing that stick on the door. These can be used to blow hinges off or to actually tear an opening in the door large enough for a person to get into, just like that. Another option is to use special shotgun slugs that are designed to shoot the hinges off. Now, these slugs are usually made of pressed powdered metal or ceramics. This avoids ricochet and potential damage to anyone inside the room. We're going to take a look at a couple of these applications right now.
These are the two explosive cutting charges that we've designed to enable officers to instantly cut the locks or hinges off a door. It's much faster and much safer than the old-style procedures of kicking or trying to use a battering ram. We have the Model 530 and the Model 531 charges. The Model 530 has approximately half the explosive that the Model 531 does. We've found in practice that the Model 530 works for any hollow core and most solid core doors. If you have a very heavy door or the standard industrial hollow metal doors, we'd recommend using the Model 531. The Model 530 utilizes 3 explosive-filled cords, whereas the Model 531 utilizes a plastic explosive that is extruded from a hydraulic press under pressure in the form of a V. It makes a much more efficient cutting charge. Both of these charges are fired by means of our little Instadet firing system. It consists of a blasting cap, a 20-foot length of flash tube, and a fused firing mechanism. In use, the blasting cap is taped to one of the cords, the ends of which are sticking out of the cutting charges. You peel the covers off the sticky tape off the charges, walk up, stick them over the lock, pull the pin in the firing mechanism, toss it gently to the ground. 1 second later, a micro-detonator will fire and send a flash of fire down the inside of that hollow plastic tube at 6,000 feet a second. What this means is you have essentially instantaneous, remote, non-electric detonation of the cutting charge. What we're going to show you now is how to use a variety of these small sectional cutting charges to cut not only the locks off the door, but also the hinges, as well as flash a cutting charge and a thunder strip that we're going to slip under the door. The key to getting several of the explosive charges to fire essentially instantaneously is using a ring main system. That's a length of explosive connecting cord that runs all the way around the door. Your blasting cap is attached to the two ends of the cord as they come together, just by using the tape that comes with the blasting cap. Then the charges can be set over the locks. You would normally peel the sticky tape off, set them right over the lock. They would be taped. Each of the ends coming out would be taped to the connecting cord. As we go up around the connecting cord, we come to the first hinge. We set an explosive cutting charge over the hinge and tape the two ends to the connecting cord. Go on down to the next hinge, if there were a center hinge, set the charge over that, tape the ends to the connecting cord, drop down to the third hinge, and set the charge over that, and tape the ends to the connecting cord. Then, if we wish to use a kicker charge, we could tape a thunder strip to the door, cut off the fuse mechanism, and set the end of the flash tube under the cutting charge, so that when the charge explodes, it will send the flash down the tube and about a few thousandths of a second later cause the thunder strip to explode. Now, when the cutting charges go off, when they detonate, they send out a very quick, high-pressure, high-velocity jet of gas, which will instantly cut the locks off the door. but it's so quick it would just go right through the door and it wouldn't give it any real push. That's why we use the thunder strip. While it gives a very loud blast in comparison to the high explosive charge, it's actually much slower, and it'll give more of a push to the door to help kick it open. Then if we wish to have a blast inside the room, we would take another thunder strip and slide it under the door, take the end of its cord, and put it under one of the cutting charges. So it will also flash. Or we could take that thunder strip and tape it over a window nearby if we wanted to blow the glass out. When you're ready to fire, you just back off, and we have a 20-foot cord. This is daisy chained. You can extend it out. You should, anytime you're using a cutting charge, be behind physical protection, because even though these charges have no metal, they're just foam and explosives, so there's no danger of back fragmentation, you can get secondary fragmentation from pieces of door jamb. We've seen that happen. So you want to be behind physical protection, either a ballistic shield or around the corner. When you're ready to go, you just pull the pin on the firing mechanism, look at your team, give them a 1, 2, 3 count, and drop the mechanism. 1 second later, all the charges will fire essentially instantaneously, cutting both the locks and the hinges off the door. The thunder strip will explode, kicking the door in, and the strip inside the room or over the window will explode. And all that happens in just a couple of milliseconds. I'm now going to demonstrate the other two types of explosive flexible linear cutting charges that we manufacture. We have the Model 520 and the Model 521. The difference being the Model 520 consists of a 3.5-foot length of soft flexible foam in which we've installed 3 cords loaded with high explosive. It has a total explosive weight of 300 grains per foot. It comes with the sticky tape on the front of the strip and the 2 end cords where the blasting cap would be attached. If you're ready to fire one, you just take the tape off the cap and tape it right to the end of the explosive cord. They can either be used to cut a door across. They can very easily be formed in a donut shape to cut a firing port right through a door, or a port we could reach through to unlatch a door, move a crossbar, whatever we want to, or come through walls or down through ceilings. Or 2 of them can be attached, one from the floor and then a second one just stuck together so the cords overlap, and you can actually split a door in half on its entire length. The Model 521 is essentially the same, except it utilizes a plastic bonded explosive that's been extruded from a die in a hydraulic press. It has a heavier charge equivalent to 500 grains per foot of explosive. Its use would be for the heavy metal industrial type hollow metal doors. To cut a firing port through a door or a wall, you simply approach the door, place the explosive charge against the door like that, move back, detonate the blasting cap. That will detonate the charge. This is the result of the Model 520 flexible linear cutting charge in the sausage type configuration on this door. Now this turned out to be a hollow core door, a very weak, flimsy door. We had probably 3 times the explosive power we needed. Had the door we used the Model 520 on been a heavy solid core door, 1 3/4 inch heavy solid core, this is the result that you get. A nice circular cut, clear through the door. This is what it would appear like on the inside. As far as the criminals were concerned, they'd be sitting in the room, there would be a blast, and about 2 seconds later, this is what they would see coming at them.
This is a typical laminated master type padlock. These are getting harder and harder to open, more and more resistant to opening. Shackles are getting hardened. You can spend an hour hacksawing away on a hardened shackle and not get through. They're getting bolt cutter resistant, although this one probably still could be opened with bolt cutters. What do you do when you're in this situation? Well, you can try and pick it, although that's getting tougher too. Or we found a tool that we like, made particularly for this application. This is called a duck bill, for obvious reasons. Heavy duty wedge, lots of mass. Now what this does, it doesn't knock the lock off the chain, rather place this in the shackle area, then you strike the back side of it with a sledgehammer. In theory, this wedges it in deeper,
causing an unnatural pulling pressure against the shackle should force the shackle out of the lock. We'll give it a shot here and see if it works. 2 shots. And as you can see quite clearly, popped the shackle. Oh, it didn't pop the side that should be opened. The weak side on this lock was the other side of the shackle, but it doesn't make any difference to us. Opened the lock quite successfully. This is a Master 2001, one of the best padlocks on the market. Case-hardened steel shackle, almost impossible to hacksaw, is impossible to cut with bolt cutters. 2 ball bearings on either side of the shackle hold it in the case itself. Very difficult to get open, impossible to shim. We're going to try the duckbill attack on this. That's going to take 2 of us because it's a bit harder lock to do. But we'll try the duckbill and see if we have any luck with that. Frankly, I think it's going to end up being a testimonial to Master Locks because this is such a good lock. But we'll give it a shot. Just kind of hold that. Hopefully I'll hit it this time. See, we shouldn't be wedged in there is the problem. Do it. And there, in 2 strokes, because I went an extra one, and it did it. Look at this. Look at this. 2 strokes opened one of the toughest locks available. Wonderful device. This is available from Be Safe Industries. It's called a duckbill, and I'll tell you, worth every cent. Nice opening tool. Here we have the most popular lock in the world, bar none, a Kwikset. Kwikset's come in a number of various designs, designed for inside houses, entries, etc. They're far and away the most popular lock in the world, and probably on a door in your house, probably an outside door. Here we have a $20 tool made from some polyplastic piping, a couple of bolts, and eye bolts. This tool uses a blank that's been cut down, slips into the Kwikset that has an eye bolt on it. To use this device, we insert the blank into the lock, put the pipe over the lock. We have a washer and a nut, which we apply but don't tighten. Then we turn the device a quarter turn counterclockwise. And then we stick the anti-twist bolt through. Goes through a slot. We have a nut for that, which we also, of course, don't tighten. This prevents the key blank from turning in the lock. Now, the object of this is not to unlock the lock, obviously. What this tool should do is grab the inside cylinder and yank it out, which of course would let us open the lock with a screwdriver if it works. Once it's in, we turn it another quarter turn until we reach resistance. At this point, we grab the back of the bolt and turn it. Now this is pulling against the Kwikset clips, which hold the interior cylinder in. There are 2 clips inside the lock. So as we pull this, screw this rather, we're pulling against those clips. We begin to feel tension. Keep going until you hear a crack or a pop. Then you pull it out, and as you can clearly see, the cylinder of the Kwikset lock has been cleanly, without damage, yanked out of the lock and into our tool. So in a few seconds, you have attacked and successfully removed the working parts of the most popular lock in the world. Hasn't damaged the cylinder. We still have the clips. You can see the clips that hold it. We can put it back in the lock. More importantly, we can stick a screwdriver in, turn the lock mechanism, and open the door. One of the best ways to get into a lock is picking. It doesn't damage the lock. Unfortunately, it requires a considerable skill level. And we're not going to try and teach picking in this video. In fact, I'd refer you to our other video, B&E, for details on picking, raking, and impressioning, among other things. But a couple other things I want to say about it here. If you have some experience, you can sometimes sight read a lock. By actually looking in the lock, you can get a rough idea of where the pins stand and what kind of rake or what shape pick to use. This is especially true when using rocker picks. My experience, and also talking to several other locksmiths who are good at this sort of thing, is the way to try and pick is to first take, if you have access to it, our electronic pick, our Cobra. Now this can be adjusted in length of throw and tension, so you can adjust it for different doorways. Second choice is the pick gun. It's about $40. Most of you probably have it. Snap gun. Third choice, if you don't have these, or if the first two selections don't work, is of course take and try and rake it. After that comes individual picking. First, we're going to start with the electronic pick, the Cobra. We've adjusted the throw to be fairly short because it's a small keyway. Insert a tension wrench in the keyway. Put the Cobra underneath the pins. Vibrate it, add tension, relax. I did it. Let's relock it and try a snap gun. Same theory, tension wrench in, snap gun underneath the pins. Relax it, bring it back. Snap it, relax it, bring it back. Let's relock it. Try raking. Lock it down. You can use our handy dandy little key ring rake. Tension wrench in. Tension on. Tension off. Tension on. Tension off. Back it up. Shows you approximately the different lengths of time it takes somebody at my skill level to use the three tools to pick open a lock. Even a fairly easily picked lock, that's about the correct ratio. This is the HPC tension tool. You'll notice there are little numbers written around the dial. On this side I've got two prongs, one long and one short, and the outer dial moves as I apply tension. Use this, you insert the prongs in the keyway. That leaves you a hole in which you can stick the rake pick, snap gun, whatever you want, and you apply tension. Now I can see how much tension I'm applying by watching the numbers. Back it off, apply it again. It's very convenient to hold. You'll notice that the keyway is clear of the picking needle. Okay, now I can see I'm about at 2. Does that do it? Nope, not quite. Back it off. This is going to be a fairly high tension lock, 3, and that got it. Very worthwhile little investment. You're going to practice picking, any kind of picking. Locks that control deadbolts, rim cylinders like this Medico, the cam, or mortise that have a shaft behind. Can be very high security. This has an angle cut key, almost impossible to pick. How do you open these types of doors if you need to get in and don't care about damage? The quickest method we found, use the K tool. Put it on, pry the lock off, rip it out. Open the lock with a screwdriver. If you can get access to the lock, you can buy a $15 cylinder wrench which fits over the lock, and as you apply pressure, adjusts itself to the lock, allowing you to turn it and rip it out of the jam. This is usually impossible if the lock has a guard ring around it, preventing entry. Third fastest method, drilling. No, not drilling the cylinder. These are very high security, hard plate cylinders, very difficult to drill. There's an easier way. This is a new drilling jig on the market. To use it, you simply put a blank or a cut key of the same type in the lock. We're using a Schlage here. Adjust it so the rig can fit down over the key. Tighten the rig on the key using its Allen wrench. Take a drill, use the rig as a guide, and drill into the set screws of the lock. Even with this lightweight drill, we can get in, get through the set screw, remove the cylinder from the door, reach in with a screwdriver, open the locking mechanism. This is a new kit on the market. It's called the breaker kit. Consists of a couple of pieces, a drill guide, handle that screws into it, a very good hardened bit. It will go through most locks almost instantly. To use this, you line the drill guide up with the cylinder, the drill bit in, and drill. Once you've drilled into the cylinder, many cylinders can then be popped out. If this one can't, take the other piece, which is the breaker, screw the handle into the breaker into the cylinder, twist it in the direction that cylinder opens in, and that will twist the cylinder loose. Now this can be used by itself on some locks. It's real good for padlocks. It's real good for rim and mortise cylinder locks, breaking it loose. Once you've got it loose, cylinder can be just popped out that easily. Here's a quick tip for impressioning a lock. This is not meant to be a complete detailed look at impressioning. For that, see our other film, B&E A to Z. And of course, normally we'd be using vice grips or an impression holder. I've coated this key with ultraviolet ink before we started impressioning. Then by shining black light on the key, the areas that still need to be filed, the pins, where the pins have rubbed the ink off, becomes visible. This is a very nice shortcut to impressioning a key. It's also possible to use nail polish, or you can see it there, or shoe polish, but the ultraviolet method works very well. In fact, while we're on that subject, suppose you want to get in a push button lock. This could be mounted on a door, in a safe, whatever. For some reason you need the combination. One way to do it, to get an idea of what numbers, is to coat each button with ultraviolet ink. After someone comes and presses the combination, the buttons that have fingerprints on them will show up quite clearly. This is a look at the Z-Tool set. This set uses one main tool to open about 600 different models from the 1950s through the present. The tool is augmented by a couple of plastic wedges, a window spreader, and a wooden stick to help hold the window open. The secret of the Z-Tool is look the type and model of car up in the book, refer to the diagram for its particular type of locking rod, and then apply it. The tool is designed to be bent so it can creep around anti-theft devices in most cars. You simply unbend it afterwards. The small end of the Z-Tool consists of a double bited sawtooth edge. It's quite sharp, can reach inside windows and grab rubber, metal, and plastic buttons and releases and pull them loose. This is a look at the high-tech brand of opening tools. You'll notice you get a hoard of tools plus a wedge, a Slim Jim. Tools are all color-coded on the handle. You open the book page for your particular make and model, and it gives very detailed instructions on the locking mechanism, including photos in some cases, and exactly which tool will open it. These tools require very little, if no, bending. They'll open virtually every car out there right now. Whole kit's about $100. Got a small mini manual you can carry with you and not have to lug the big one around for the most common jobs. Easier than the Z-tool because they're pre-formed, also more expensive. Z-tool's about $40.
Underwriters Laboratory rates safes as to the level of protection that they offer. Money safes must weigh 750 pounds. Most have round doors. These are given ratings based on the number of minutes they will resist an attack by a professional lockman with the proper tools. Let's take a look at some safes, both money and fire, and methods of attacking them. The first safe we're going to look at is a cutaway of a fire safe. It offers only a minimum of protection. It's not considered to be against burglars. Even though there is a hard plate in the safe to frustrate drilling, the outside is made from mild steel only, and the wheel pack has very minimal protection. The safe is full of stabilized water and other insulation materials held in place by these baffles to prevent heat from reaching the money inside the safe.
Okay, as we see here, when the correct combination is dialed, the bolt retracts, therefore allowing the locking bolt retracts, therefore allowing the door bolts to also retract, thereby opening the door. If you notice, this is approximately 1 inch steel, and there are other mechanisms to lock the door in different places. These control also the 1 inch bolts, 1 inch steel bolts. If a burglar had the opportunity to drill out this locking dog, they would free this up, thereby allowing the door to open. Or if somehow the burglar attacks the wheel pack and after drilling on the wheel pack or the dropping lug allows the bolt to retract, thus again, it'll free up the safe door. As I explained to you about a fireproof safe, the major reason for the existence of the safe is to dissipate heat, to keep it under 350 degrees, to preserve paper contents. This, if you look at it, has a 1/4 inch steel outside shell, which means practically anything can drill through it. And of course, the thickness of this is really to contain the insulation or the solidified waters, as we talked about in the previous cutaway safe. The bolts, again, are 1 inch metal bolts. Now, this particular safe does have a relocking device, thereby if any individual punches the dial, removes the dial, and punches the line in, it will automatically lock to prevent the handle from opening. This, of course, on this particular safe, one would only need to drill a hole right about here where the locking bolt is, drill out the locking bolt, thereby allowing release of the locking dog and door opening. This is a Diplomat series, and again, this is a combination of key and dial. Again, these are very fire-resistant safes. They have good insulation, yet they're shielded by only 18 gauge steel. The safe that we have in front of us is a burglary-resistant safe. It has no rating, yet the design in itself allows it to be both burglary and fire. These are usually encased in concrete, the best insulation there is, and therefore it can maintain temperatures below the standard 300 degrees inside temperature. This is a key change dial, which means that, again, the hole in the back, you insert a safe key, change key, and dial a combination you like, and that's all there is to the safe. Very cheap, very functional money safe. And this type you'll see majority in the gas stations. Before, this type of safe by another company allowed one to take a sledgehammer. If you hit this area hard enough, all the bolts would break and allow the head to open. The majority of these safes that we've described for convenience stores are burglar-resistant safes. If you were to look at the door, you can see instead of gauge steel we're talking about, we are now talking about 3/4 inch, 1/2 inch steel. This is 3/4 inch mount steel. The entry of these are, again, conveniently, the entry of these safes are designed so that no pry bar can be inserted in and a door attacked. Everything must be done by drilling. This is a better security safe than the ones we looked at. If you look, it's it looks like 12-gauge steel welded together to allow the door, and all this is, again, insulation. If you notice the bolts, it's a 1/2 inch metal, very easy to get to. If the combination is ever forgotten, or if your key is ever misplaced, there is a keyhole on the side to allow entry by this key. Again, the keys can be picked. If you notice this door, it is all mild steel. However, the hard plate and majority of the protection is on this door. The TL15 rates for this door only. To attack this safe, one only needs a good, strong, heavy-duty drill, where one would drill through the top. Entry to the door, here, into the wheel pack, and from there you would read the wheel packs. You would have your own combination. Thus, you avoid all the hard plate and protection on the front door. This is a TL30 cash guard by die bolt. If you notice the massive bolts and the way they extrude much further than any fireproof safe or any TL15 that we have seen. Look at the 1-inch steel, 1/2 inch steel, and the plate. We know that this safe means business. Look at this door, this massive TRTL 15x6 door. We see the 1/2 inch to 2-inch bolts. We see the thickness of doors all around. It translates to the same as the wall. Because this is a by 6, all 6 sides are protected with the same type of protection as the door. As we go through the wall, we see the materials designed with the same materials as that of the door. Mechanical tools like carbide and diamond tip drills, impact hammers, diamond grinders, thermal devices like oscillating torches or lances cannot get through there, at least for 15 minutes. When the incentives are high, burglars will not hesitate to spend weeks evaluating risks and setting up a powerful set of resources for the job, and this safe is designed to protect against that for at least, again, 15 minutes, all 6 sides.
Suppose there was an emergency situation and you had to get through a solid brick wall, quietly, quickly. Could you do it? No way, right? Onto the brick.
No, that's fine. That was fine.
Whoa! This is an exothermic torch. Very versatile device. Contains pure oxygen, regulator, hose, 12-volt rechargeable ignition system. Comes out to this hand grip that controls the oxygen. I press the grip, I get oxygen. This is steel, hollow inside, covered with copper, but it's steel. What this does, when we rub it and turn the oxygen on, which I'm not doing right now, we get ignition, very easy to light, lights the torch, the oxygen flowing makes the steel burn. 10,000 degrees at the tip of this. This will vaporize anything in the universe. It's that simple. It's difficult to plug this into something and cut into it, but to poke holes or to gouge in everything from bricks to hard plate, solid steel, this device will cut it. Rod lasts about 30 to 40 seconds, then you change rods. You can adjust the flow of the oxygen by adjusting the pounds per square inch. You get a hotter, more direct flame. For concrete, rocks, bricks, 40 to 50 pounds per square inch. For simple things like safes, hard plate, and steel, 10 to 20 pounds per square inch goes through it like a knife through butter. A couple of interesting things about this torch. Suppose you had a hostage situation, somebody inside a brick or cinder building. You wanted to get a viewing device or a rifle barrel through a hole quietly. Light the torch, stand outside, poke through. Measure the time it takes to go through the same kind of brick or same kind of cinder. The last quarter inch, stop, pull it out, put a chisel in, tap a hole in. You've just about silently punched a hole in any building known to man. Suppose you don't want to be seen doing this. Pull a van up, park it directly against the building, burn through the building, and if necessary, burn through the van. Quiet, very hard to see. If necessary, put a little tarpaulin up, nobody can see the flame. This device goes through anything. Now, you've got to remember, if you're going into safes or some area where there are valuables involved, it will burn money, it will burn anything else as fast as it burns steel or faster. So you've got to be a little careful with it. You can relock locking devices, fuse relockers together if you're not careful. But it is so much faster than drilling and so effective that it's pretty close to magic.
Let's see, I'll show how fast it goes through a piece of 2-inch thick, well, 1-inch thick steel and hard plate. As you can see, we went through all or most of this safe lid, our test safe lid, in just a few seconds there. The reason you wouldn't probably want to do it quite like this is rather obvious. It makes a big mess. I've used it a number of times in related work, though, when we're opening safes. One example was when I was working on a fast food restaurant that had been burglarized, and all the relockers on the safe had been set off. This was an excellent way to get through the hard plate so as to destroy the relockers to enable us to get the safe open.
What's the one thing most safes have in common? What's the weak point of most safes? The dial mechanism. Safe manufacturers, as a rule, do not manufacture their own dial mechanisms. As such, there are standard designs used on most safes. This provides a weak point that can be exploited to open most safes without too much trouble. This is a Sargent & Greenleaf 6730. It's the most common safe lock in the world. Ours is mounted obviously as a cutaway so we can see what's going on. Normally it would be enclosed. We're going to look at the lock. We're going to look at a number of attacks. Devices in front of me come in a kit, and we think it's probably the most effective quick safe attack there is. We've got a drill guide, alignment and opening tool, and 4 plastic emergency dials. The reason for the dials is most attacks entail removing of the safe dial. On the Sargent & Greenleaf, as with most other safe locks, we have a wheel pack. In this case, it's a 3-wheel pack. The slot lines up under this locking bar when the combination is dialed. Then the slot engages the bar and opens the release lever, the latch. You turn it farther. This is how the safe normally opens. Now you'll notice that this does have a relocking device right here. if you punch out the wheel pack, which is the conventional method of safe attack, simply by ripping the dial off and then punching through all this, this relocking device will fall into this hole in the bolt, stopping the safe from opening. One way to defeat this is to then drill through, grab the relock device with a wire or a tool made especially to do that, and pull it back out of the bolt, allowing normal operation of the bolt. However, there are much more convenient attacks with today's technology. In order to remove the dial cleanly, we're going to use a device that should be familiar to most of you. It's a slam hammer. This particular one has been enlarged so it will fit over a safe dial. It has Allen screws, so you can actually tighten the device down on the dial and then use the momentum of the weight to yank the dial off. This removes the dial quite cleanly and does not affect relocking devices, which is important if we want to open the safe after we yank the dial off. So remove the dial, and we've already removed this one by slamming it. Leaves you a nice clean spline, and you're ready for the next step. The next thing we do after pulling the dial is remove the dial ring. This piece right here, which is held on with 2 small screws. Very easy to remove. At this point in time, we have several methods to choose from. The first, and probably least effective, is to take a book, such as this one, which details most safes in existence and what kind of locks they have. It then gives information regarding the rating of the safe, where the fence is, if it has a relocker, how the combination works, and exact drilling information, such as remove dial, up 7/8 of an inch, left 1/8 of an inch, line fence with wheels. Very handy little thing. As I say, it covers most safes you'd find. A faster method, if you know the type of lock you're going to be dealing with, is to get a template. This is a magnetic template for this exact lock. In fact, it would stick on here if I wasn't using a plastic front. It shows exact measurements of where and how to drill to prevent over drilling so you don't destroy the wheel pack, where the relocker is, drill points to drill out the relocker. You can put it right on and use it as a drilling guide. Very handy, very effective device. An even better one comes with our little opening kit. This is a drill guide. The guide fits on the lock and screws into the 2 holes that actually held the drill, the dial ring on the lock. At this point, one simply takes a hardened drill bit, drills into the hole required, being careful not to drill too far, and using this as a drill guide. This supports the bit. At this stage, we turn the dial several times to clear the pack. Then we insert the probe that comes with the kit. The probe has an eccentric tip, which we rest on the furthest wheel pack and then dial it. As the slot comes around, the tip drops into the wheel pack. You record this number. Now, this sequence is then repeated, the correct dialing sequence, for every wheel pack. You'll feel the tip drop in as the slot comes around 3 times, and you have a series of 3 numbers. Now, this is quite easy to feel. It takes no special manipulation, touch, or technique. The only problem is lining it up on the correct wheel pack, which takes just a real little bit of practice. Once you have these numbers, you consult a chart for the correct add-on numbers, and that gives you your opening combination. It's a very effective method. If you practice a little bit, you should be able to open the most safes in about 5 minutes. You know, I sometimes wonder if there's really any magic left in the world. It may be in arts like ours. High technology, low technology, how to get in things, how to get through things, cars, houses, buildings, safes. By the way, this trick really works on almost all Volkswagens.
Here we have a typical fairly heavy wooden deadlocked, dead-bolted door, difficult to open. Of course, we can pick the lock, we can chop through the door, a number of ways to get inside. One of the things we want to accomplish in this is to start thinking of ways to go through. In other words, to circumvent the lock. We don't have to unlock this door to get in if it's done right. All we have to do is go through this obstacle. One of the ways to do that is probably just popped deadbolt loose out of the door. Doesn't leave any permanent damage, makes a few marks, release the pressure, see the jam come back in, so we do that. This is the Omni jam spreader. Obviously it's on a fairly easy door. We don't have a deadbolt, however the door is locked, and the latch extends quite a ways into the wall. We've already set it up here. Could be a little more horizontal, but we're going to try anyway. Give it a couple squeezes here. You can hear the frame starting to go. And see what happens. By God, now watch. You didn't hear much there because the door opens outward, so it's hitting the lever of the jam spreader. So we take the jam spreader off the door. Now you notice it's still locked. All we did was spread it away from the jam, approximately ½ an inch, enough to let the latch slide out from the door. We shut it again, and the door is locked. That's how the jam spreader works. There's not a lot of damage. In this particular instance, because these are sort of stuck on the jam, it is beginning to pull these loose as we did this. Both of these are pulling loose a little bit. And if you look closely, you can see some marks where the jam spreader sat. However, for the most part, not a lot of damage. It opens the door, doesn't harm the lock, doesn't harm the jam if it's done right. A few seconds, you're in. These are an example of state-of-the-art opening tools. They're designed for emergency opening situations. They work well for that. They also work well for normal opening situations. These two tools are very similar in nature. They're hydraulic openers. This one is called the Hydroforce and is made by Iowa American. This one is called the Rabbit tool, and it's made by the same people that make the Jaws of Life. The way these work: apply hydraulic pressure by pumping, forces the door back and open. In about 20 to 30 seconds, these tools will literally rip open most doors, be them hollow core, solid core, whatever. Well, you have to remember we're dealing with high pressure hydraulic fluids here. We have to take certain precautions. But if you handle these right, you can walk up to a door, stick it in, and open the door. Really amazing tools. These tools, a number of years ago, people came up with the idea of taking a car jack, usually a hydraulic jack, for instance. You can tell that this exerts quite a bit of pressure. It'll lift up an American car. You can take the jack, put it in between the jams. It's theoretically possible to move this massive wooden jam with enough pressure over far enough to let the latch, even in this case an inch, inch and a half deadbolt, come out of the door. Now, obviously, jack isn't going to make it all the way over. So the way people did this was took blocks of wood, propped the jack up, tried to extend it out as far as they could, put other blocks of wood in front of the jack to press against the jam. From personal experience, I can tell you this is really rough. A lot of jacks don't work upside down. The wood will bend, the wood will pop loose. It's a very cumbersome, inefficient operation. A screw jack is sometimes a little bit easier. The trick is to get as close to the jam as you possibly can if you're going to use one of these. Well, a couple years ago, somebody took this concept and thought, you know, I can do a better job. And as such, we have a tool known as the jam spreader. This is manufactured by Omni Concepts in Vista, California. It's also sold by Schomertech, a number of other people. Same principle. It's a hydraulic jack. easy to extend the legs all that distance, get it in tight on the jamb. Got a handle, folds up, store, hydraulics, on and off. This will put out about 4,000 pounds of pressure in order to spread the jamb. That is enough to spread most jams without too much damage. Will not spread heavy metal jams in large buildings. We've got the jam spreader in place. It's horizontal, the correct side is up, tightened down. We're as close to the jam as we can be comfortably. We're going to apply pressure. You're going to hear the jam creak as it starts to spread open. It's moving the jam away from the door. You can hear that noise. Pulling the deadbolt out of the door. Now this is not a huge deadbolt, but it's reasonably sized. We're going to apply this pressure. I can feel the door starting to go right now. It's creaking, giving way.